We tend to think of our universe's laws as, a lucky roll of the cosmic dice. But what if that's not the case at all? What if the very geometry of our reality was never a choice, but a mathematical necessity? We're about to jump into some new research that claims exactly that. And here it is, right from the source material. This is the central claim. And it's a huge one. It really reframes our entire understanding of reality, the idea that the large-scale structure of our universe had to be the way it is. So you have to ask, what's the mathematical proof behind a statement this powerful? It all kicks off with something called Lovelock's theorem. Now, this isn't some newfangled idea. It's been around since the 70s. It basically says that if you've got a stable four-dimensional universe, like ours, Einstein's general relativity is the only game in town for describing gravity. This theorem is the foundation for everything else we're about to explore. All right, so let's set the stage. How does this forced geometry actually work? This is the framework that seems to lock our reality into one very specific shape. The whole theory works by doing something called a dual null source split. It's kind of like neatly separating the ingredients of a recipe from the bowl you're mixing them in. On one side, you have the propagating sector. That's all the stuff in the universe, like matter and radiation. And on the other, you've got the background sector, which is the very fabric of space-time itself. The math shows you can treat these two as completely separate things. And this is where things get really interesting, because our cosmic detective story is about to begin. While this model is incredibly solid, it actually created a huge, colossal problem, a real mystery of cosmic proportions. So the model is great at describing the vacuum of space, right? But it has absolutely no explanation for where it came from. The math all checks out for how it behaves now, but trying to actually create that vacuum today is, well, it's pretty much statistically impossible. And this number right here, wow, it shows you just how big the problem is. If you tried to create the vacuum of space today through, say, a quantum fluctuation, that process is suppressed by a factor of 10 to the power of 256. That's a 1 with 256 zeros after it. A number that huge is basically zero. So the idea of creating the vacuum today, it's just dead on arrival. The researchers called this the population origin crisis. I mean, if the vacuum couldn't be made today, it had to have been made some other way, right? So they started an investigation, following all the mathematical clues to figure out where the fabric of our universe really came from. So the investigation zeroed in on three main suspects, or pathways. The first path hoped some small quantum effect could somehow beat those impossible odds. The second suggested the vacuum was a frozen relic from the very beginning of the universe. And the third path proposed there was a special window where the rules were different, making it easy to create. Okay, so path one? It got rolled out almost immediately. The quantum prefactor is a pretty small number. Trying to use it to overcome a suppression of 10 to the 256, it's like trying to stop a bullet train with a pillow. It is just not going to happen. Now we get to the key piece of evidence, the I condition. Think of this as a cosmic law of persistence. It says that for any structure to have survived since the dawn of the universe, its bounce action, which is kind of like its stability score, has to be over 140. Anything less than that would have just decayed away eons ago. And that I condition, that minimum stability score of 140, is what completely took out our third suspect. The low action window path was all about having a stability score near 1, which would make creation easy, but the I condition demands a score over 140 for survival. So anything with a score that low would be incredibly unstable and would vanish almost instantly. There's just no way a persistent vacuum could come from this path. So with path 1 and path 3 both eliminated, there's only one suspect left standing, the frozen relic. The idea that our vacuum was created in the crazy high-energy environment of the early universe. But the researchers needed definitive proof, a single piece of evidence that would close the case for good. They needed a smoking gun. And so they designed one. They called it the Y-discriminant. It's a single number, calculated from all the cosmological values we already know, and it was designed to be the final absolute test. It would tell them, once and for all, how the universe was populated. So they crunched the numbers, using all the observed data from our cosmos. And this is the value they got for the Y-discriminant. An absolutely massive number, 10 to the power of 198. Of course, a number that big doesn't mean anything without context. So what does it actually tell us? Well, the test was super simple. If Y was greater than 1, it proved the vacuum was a non-thermal frozen relic created way back in the unique conditions of the Big Bang. If Y was less than 1, it could have formed later. And since 10 to the 198 is, just a tiny bit bigger than 1, the verdict was crystal clear. And just like that, case closed. The evidence is just overwhelming. The fabric of space isn't something that can just pop into existence today. No. It's a frozen relic, a leftover from the incredibly high-energy furnace of the early universe. So, what's the big takeaway from all this? Solving this mystery reveals something really profound. It suggests our universe isn't just a set of passive rules. It's more like an active, self-regulating system. The researchers actually call this system the Samson V2 controller, and it functions just like a PID controller you'd find in any engineering project. The P, or proportional term, that's the elasticity of space-time itself, which makes immediate corrections. And the I, or integral term, that's dark energy. It represents the accumulated history of all the tiny errors over cosmic time. And together, they work to keep the whole system stable. And what target is this controller trying to hit? It's called the Mark I attractor, a universal constant around 0.35. This ratio basically acts like the set point on a thermostat. The Samson controller is constantly making tiny adjustments using dark energy and space-time elasticity to keep the universe right around this ideal stability number, stopping it from collapsing on itself or expanding apart forever. Okay, so let's just do a quick recap of what we've unpacked here. The actual shape of our universe, its geometry, seems to be a mathematical necessity, not some random coincidence. The vacuum of space is a leftover from the Big Bang, and maybe the wildest part? The universe seems to be a dynamic, self-regulating system that uses fundamental forces like dark energy to actively keep itself stable. And that really leaves us with a final, pretty mind-bending thought. If this model is right, and our reality is basically a self-regulating computational system that was forced into existence by its own mathematical logic, well, what does that imply? What other fundamental rules is it following? Right under our noses, just waiting for us to discover them.